everybody. Today we are going to be concluding our lessons on quadrilaterals and talking about our final two quadrilaterals, trapezoids and kites. So our objectives for today are that students will be able to recognize and apply properties of trapezoids and kites. Let's get started. All right, let's start by talking about trapezoids. Now, there are two different kinds of trapezoids that we're going to talk about. The first one is a non-isosceles trapezoid, and the second one is an isosceles trapezoid. So let's first focus in on non-isosceles trapezoids. Properties of non-isosceles trapezoids are that there's only one pair of opposite sides are parallel. So in this figure, this side is parallel to this side, and it's indicated by these little arrows. That's the only pair that are parallel. These two sides are not parallel. Also, consecutive angles of a non-isosceles trapezoid are supplementary. So what that means is if we were to, let's zoom in on our trapezoid. Let's call this angle, let me get my pen. Call this angle 1, call this angle 2, angle 3, and angle 4. What that means is that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. They're supplementary. Also, the measure of angle 3 plus the measure of angle 4 equals 180 degrees because they're supplementary. All right, just like a parallelogram. Now, if we're talking about isosceles trapezoids. So in an isosceles trapezoid, which looks like this, it has all the same properties as non-isosceles trapezoids. So one pair of opposite sides parallel, consecutive angles supplementary, and it has these additional properties. So in an isosceles trapezoid, we also say that non-parallel sides, or the legs, are congruent. Just like an isosceles triangle, right? The two legs are congruent. In an isosceles trapezoid, the two legs are congruent. Also, the diagonals of an isosceles trapezoid are congruent as well. So if we were to mark this up, we would say, let me get my pen, the diagonal is congruent to the diagonal. Now, in an isosceles trapezoid, the base angles are congruent as well. So what that means in an isosceles trapezoid, this angle is congruent to this angle. Those are the base angles. Also, this angle is congruent to this angle too, because those are base angles as well. And last but not least, opposite angles are supplementary. So, not only are consecutive angles supplementary, so this angle and this angle are supplementary, this angle and this angle are supplementary, but also opposite angles. So this angle and this angle are supplementary. This angle and this angle are supplementary as well. Okay, so let's move on to a few sample problems. All right, problem number 1. We want to find the missing values in the trapezoids below. So in problem number 1, we're given J and L, and we can see that this is a non-isosceles trapezoid because the two sides are not congruent, the two legs. Okay, we've got parallel sides. The two non-parallel sides are our legs. They are not congruent. Therefore, it is a non-isosceles trapezoid. We also know in a non-isosceles trapezoid that the consecutive angles are supplementary. So J and M are supplementary, K and L are supplementary. So in order to find the measure of angle K, we simply do 180 minus 51. So 180 minus 51 is going to give us 129 degrees. So the measure of angle K is 129 degrees. We can mark that in our diagram as well. Now, we also know J and M, angles J and angle M are supplementary. So in order to find angle M, 180 minus 87. That's going to give us 3. Let's do our subtraction here. And we get 93 degrees. So the measure of angle M is 93 degrees. This is why it's important to know our properties and know what makes a non-isosceles trapezoid a non-isosceles trapezoid. All right, now if we're looking at number 3, we want to solve for x here. we can look at this figure and see that it is also a non-isosceles trapezoid. We're given two consecutive angles. What do we know about these angles? Think about it for a second. If you said that these two angles are consecutive angles, therefore they're supplementary, you were correct. So if we say 54 plus 8x minus 6, 54 plus 8x plus 6, it's going to equal 180 because they are supplementary. Now it's just algebra and we want to solve for x. So combine like terms and we get 60 plus 8x equals 180. Subtract 60 from both sides. 8x equals 120. Divide by 8 and x equals 15. Our problem's asking us to solve for x, so we're done. All right, number 5. In number 5, we're given that DEFG is an isosceles trapezoid. So we want to use the properties of an isosceles trapezoid that we know in order to fill in these missing segments. So we know what we're trying to look for is DG is congruent to what segment, and DF is congruent to what segment. So looking at our diagram, we know that DG, if this is an isosceles trapezoid, is congruent to EF because the legs of an isosceles trapezoid are congruent. We also know if we're looking at DF, DF is our diagonal, we know the diagonals of an isosceles trapezoid are congruent as well. So we can say that DF is congruent to GE. All this problem is asking us to do is to know our properties of an isosceles trapezoid and state what sides are congruent. All right, now if we're looking at number 7, we know this is a trapezoid because these two sides are parallel. It looks like a trapezoid, and we are given that PS is congruent to QR. So we're given that our legs are congruent. Therefore, we can say that this is an isosceles trapezoid. If it's an isosceles trapezoid, we know that the base angles are congruent and consecutive angles are supplementary. So if base angles are congruent, if angle P is 112, angle Q is also 112. So that's how we can find the measure of angle Q. Then we know that P and S are consecutive, therefore they're supplementary, as well as Q and R are also consecutive and supplementary. So to find S and R, because the base angles have to be congruent as well, all we need to do is say 180 minus 112. And we get 68 degrees. So the measure of angle S is 68, measure of angle R is 68 as well. So as long as you know those properties and you're able to identify whether it's a non-isosceles trapezoid or an isosceles trapezoid, finding those missing measures is a breeze. Now let's move on to number 9. All right, for number 9, we're throwing in some algebra into these problems and mixing algebra with our quadrilaterals. So we're given that MNOP is an isosceles trapezoid. Therefore, we know that MP is congruent to NO if it's an isosceles trapezoid, and all of our base angles are congruent, as well as our diagonals are all congruent too. If we're given that, let's see, MP is 16x minus 13, so let's write that in, 16x minus 13. We're given that NO is 9x plus 8. Oops, I wanted to zoom out. We're given that PN is 5y plus 19. So PN is our diagonal. So we'll draw an arrow pointing to that diagonal and say that that's, 5y plus 19. And then we're also given that MO, our other diagonal, is 12y minus 37. Now what we want to do is solve for x and y. So we know that our legs are congruent. We already marked those with single tick marks. And we also know that our diagonals are congruent. So let's mark those with double tick marks. Now in order to solve for x, we're going to look at those legs, Since the sides are congruent, let's set them equal to each other. So let's say 16x minus 13 equals 9x plus 8. Now let's solve for x. Move all the x's to one side. So we end up with 7x minus 13 equals 8. Add 13 to both sides. 7x equals 21. Divide by 7, divide by 7. X equals 3. And we just solved for x. Now to solve for y, our diagonals are congruent. We're given both of our diagonals, so let's set them equal to each other. We're going to say 5y plus 19 equals 12y minus 37. Move all our y's to one side. 19 equals 7y minus 37. All of our constants or our numbers to the other side of the equal sign. So we get 56 equals 7y. Let's move this up so we have some space. Divide by 7, divide by 7. Y equals 8. And our problem's asking us to solve for x and y, so we are done. All right, what I want you to do is when I say go, I want you to pause the video and try to do numbers 11 and 13 on your own. So try to do number 11 and number 13 on your own and see if you can do them. Remember that the base angles of an isosceles trapezoid are congruent and the consecutive angles of an isosceles trapezoid are supplementary. Remembering those facts, see if you can do numbers 11 and 13. So go ahead and pause the video right now. All right, so after working out number 11, first thing you should have done was set 10x minus 33 plus 4x plus 17 equal to 180 because angles J and M are supplementary because they're consecutive. So once we set that equal to 180, combine like terms, move the constants to the other side, divide by 14 to get x by itself, we find that x equals 14. Then you want to take x equals 14, plug it back into each of these expressions in order to solve for angle J and M. So we plug it back into angle J, find out that angle J is 107, plug it back into angle M, find out that angle M is 73. Then we know that angle M and L are base angles, therefore they are congruent in an isosceles trapezoid. So angle L also has to be 73. J and K are also base angles, therefore they're congruent. So angle K is also 107. So you should have gotten 107, 107, 73, and 73. All right, now let's check number 13. For 13, you should have gotten 131, 131, 49, and 49 degrees. What you should have done was set angle C equal to angle D because it is an isosceles trapezoid, therefore the base angles are congruent. Set them equal to each other. Move all the x's to one side, all the constants to the other. Divide by 3 to get x by itself, x equals 7. Then you can go back and plug x equals 7 into either one, either C or D. I picked D because it's smaller numbers, easier to multiply. 18 times 7 plus 5 gave us 131. So C and D are 131. Then we know D and E and C and F are supplementary because they're consecutive. So 180 minus 31 gives us 49 degrees. So F and E are 49 degrees. If you still have questions about this and don't understand, please raise your hand and I'll come by and help you. Otherwise, we're going to move on. All right, when we're talking about a trapezoid, there's something special about them. We can talk about the mid-segments of a trapezoid. The mid-segment of a trapezoid connects the midpoints of the legs. So E and F are the midpoints. E is the midpoint of AD, F is the midpoint of BC. The midsegment connects them. So if EF is the midsegment of trapezoid ABCD, then there's a few things that we can say. We can say that AB is parallel to DC and it's parallel to EF. So we would write that as AB is parallel to DC is parallel to EF. Also, there's something special we can say about the midsegment. We can write a formula. We can say that the midsegment is equal to the average of the two bases. So how we would write that, we would say that EF equals AB plus CD, or DC, doesn't matter, divided by 2. So we add the two bases together, divided by 2, and that gives us the midsegment. So let's do a few examples to see this in action. All right, for number 1, we're going to use the trapezoid above to solve this problem. So I put it on your screen for you. It's also right above in your notes. So if we're given that AB is 14, so let's label AB as 14, and we're given that DC is 26, we want to find the midsegment. We want to find EF. So how we find EF is we want to take the average of the bases. So anytime we're taking the average, we add them together and divide by the number of things we're adding together. So in this case, we're going to add AB together plus AB plus CD or DC and divide it by 2 because there's two sides. Add the two sides together, divide by the number of sides, which is 2. So EF equals 40 divided by 2. EF, or our midsegment, equals 20. Number 3, if we're given that EF is 22, so we're given the midsegment, and we're given that DC is 38. We want to find AB, so let's call AB X. Now we know how to find the midsegment. We add the two bases together and set it and divide it by 2, and that's going to give us the midsegment. So if we add the two bases together, X plus 38, and divide it by 2, we're going to get the midsegment, which we know is 22. This is how we would set up this problem. And then we just want to solve for X. So we can turn it into a proportion, so 22 over 1. Then we want to cross multiply. So 1 times X plus 38 gives us X plus 38. 2 times 22 gives us 44. Subtract 38 from both sides, and we get X equals 6. All right, so therefore we can say that AB equals 6, and we're done. All right, now we're throwing some algebra into the mix, so let's read the directions for number 5. For trapezoid PQRS, we're given that Y and Z are the midpoints of the legs. Therefore, if they're the midpoints of the legs, that means that YZ is our midsegment. We want to find what is YZ. So we're going to use our formula for finding the midsegment to help us first solve for X and then go back and plug it in to find YZ. So we know that if we add the two bases together, so PQ plus SR, so we're going to say 38 plus X plus 14, and if we divide that by 2, we're going to get the midsegment, which we know is 5X minus 19. So what we want to do now, turn it into a proportion and cross multiply. So on the left side, we get 38 plus X plus 14 equals, cross multiply, 2 times 5X minus 19. All right, on the left side of the equation, we've just got addition. We're just adding, so just combine like terms. We get 52 plus X. On the right side, we want to make sure to distribute the 2 to both terms inside because we're multiplying. So 10X minus 38. Then let's move all the X's to one side. we get 52 equals 9x minus 38. Let's move this up so we've got some more space. Move all the constants to the other, so add 38 to both sides. And we get 90 equals 9x. Divide by 9, x equals 10. All right, now we're not done because the problem's asking us to find yz. So we have to go back and plug x into 5x minus 19. So 5 times 10 minus 19, 50 minus 19 is going to give us 31. So our final answer is yz equals 31. And we're done. All right, so for time's sake, we're just going to skip over number 7 because it's very, very similar to number 5. If you feel like you want to do this problem, go ahead and stop your video right now. And I'm going to try to do this problem. When you unpause the video, I'll have the answer written on there so you can check your work. But if you feel like you get this, go ahead and skip over this problem. So if you decided to do this problem, you should have gotten that x was 2 and uv equals 13. You can go ahead and check your work right now. And if you need help with this, go ahead and raise your hand and call me over and I will help you. Otherwise, let's move on to the next topic. All right, the last quadrilateral that we're going to talk about is a kite. So kites are kind of like that bonus quadrilateral, because if you look at your flip book, there are no kites in your flip book, but I have such high expectations for you guys, and I think that every single one of you is so smart that I wanted to teach you about kites, and because I think it's so important to challenge yourselves, and I really want you to expand your knowledge of geometry and quadrilaterals. So let's go through kites, and yes, that means it will be on your test because we're going through it right now. All right, so properties of kites. A kite is a quadrilateral with these following properties. So a kite has exactly 2 pairs of consecutive congruent sides. So in this figure, AB is congruent to AD, BC is congruent to DC. Okay? It has 1 pair of opposite angles that are congruent. So in this figure, ABC is congruent to ADC. So if we were to mark that on our diagram, it would be these 2 angles right here. Hold on. ABC, ADC. All right. And then last but not least, the diagonals are perpendicular. So AC is perpendicular to BD. Therefore, all of these are 90-degree angles. All right, so we're going to use the properties of kites, and yes, you need to know the properties of kites to solve the next few example problems. All right, so for number 1, if we're given that this quadrilateral is a kite and we want to find the measure of angle B and angle D. If this is a kite, then we know that it has to have 1 pair of opposite angles that are congruent, and angle A and C are not congruent. Therefore, we know that angle B has to be congruent to angle D. So if we call this X and X, because we know they have to be the same, we also know that all the interior angles of a quadrilateral have to add up to 360 degrees. So what we can do is we can say that 85 plus 43 plus x equals 360 degrees. Then we want to simplify this. We can say 128 plus 2x equals 360. Subtract 128 from both sides. We get that 2x equals 232. Move this up a little bit. Divide both sides by 2, and we get that x equals 116. All right, therefore, angle B is 116 degrees, and angle D is also 116 degrees. All right, we're also given in number 3, this quadrilateral is a kite. So we're given that this angle right here is 37, and we want to find all these missing angles. So let's first start with the measure of angle PTQ. So PTQ. Because this is a kite, we know that the diagonals are perpendicular, so therefore we know that PTQ is a 90-degree angle. It's a right angle. So therefore, measure of PTQ, 90 degrees. Now, if we're given QPT and we're given PTQ, if we want to find PQT, so we want to find this angle right here, we want to look at this as a smaller triangle. It's a right triangle, all right? So therefore we know this is 90 degrees. We know it's a triangle, so the sum of all the interior angles of this triangle has to add up to 180. So in order to solve for that missing angle, PQT, we can say 37 plus 90 gives us 127. Subtract that from 180, and we've got our missing angle measure. So what is that going to be? 53. All right, so this angle right here is 53 degrees. PQT is 53 degrees. All right, then we're also looking for QRT. So QRT, this angle right here. If this is 37, we know the opposite angles have to be congruent, so that means this one is also 37 degrees. So therefore, QRT is 37 degrees as well. All right, hopefully this is making sense to you. If not, call me over and I'll help you. Otherwise, let's move on to number 5. All right, number 5 is a bit of a challenge problem, so I highly recommend that you pay close attention as I go through this problem. All right, so let's focus in on our diagram first, and then we'll go back and fill in the blanks. Sorry for that interruption. I forgot to turn my phone off. All right, so this is a reminder to you guys to make sure your phones are on silent. All right, now moving on to our diagram. Let's see. First things first, if we know this is a kite, we know our diagonals are perpendicular. So perpendicular means that each of these angles is 90 degrees. Therefore, we already found the measure of angle 3. They're all right angles, so angle 3 is 90 degrees. Now we want to look at what we know. If we know that this is 65, this is 90, we can add these two together, subtract it from 180, and that's going to give us the measure of angle 1. So let's say 65 plus 90, that gives us 155. 180 minus 155 gives us 25. So the measure of angle 1 is 25 degrees. Then we know that this is 52 degrees. This angle right here. This one's 90, 52, add them together and we'll get the measure of angle 6. So 90 plus 52 gives us 142. 180 minus 142 is going to give us, what is that? 8. This becomes a 7. 38. All right, so the measure of angle 6 is 38 degrees. Now we know that because this is a kite, these angles are congruent. So 65, if this angle is 65, angle 4 has to be 65. If angle 6 is 38, angle 5 has to be 38. So let's mark that on our diagrams. All right, we know this because the entire thing has to be congruent. So 65 plus 38 is going to give us 103. So this entire angle is 103, this entire angle is 103 as well. All right, and then we also know that this diagonal is going to bisect this angle. So angle 2, if angle 1 is 25, angle 2 is also 25. If this angle is 52, angle 7 is also 52. All right, and we can confirm this by adding together these two angles, so 103 plus 103. 103, 103 gives us 206. We know all the interior angles of this kite have to add up to 360. So 360 divided by 106 is going to give us 154. If we were to add together this whole angle, we get 104. This whole angle gives us 50. So that's the 104 degrees that we needed. If we add up all those sides, we're going to get all those angles, we're going to get 360 degrees. Therefore, we just found all of the missing measures of our kite. So now let's fill in Oh no! Alright, so if you want to go ahead and fill in these numbers over here, we're not going to be able to go back and look because, oh, there we go. For some reason, this is acting up. Alright, so let's use what we know. Let me see if I can get rid of some of these. Alright, oh well, it's not going to work. Let's just move over here and fill these in. Alright, so the measure of angle 1 is going to be 25, we found. Alright, you can rewind the video and see that. Measure of angle 2 is also 25. Measure of angle 3 was 90. Measure of angle 4 is 65. Measure of angle 5 is 38. Measure of angle 6 is also 38. Measure of angle 7 is 52 degrees. Alright, so we found all of these angles. I'm sorry, my iPad is glitching up and we can't look at them as we're labeling them here, but they're all correct and you can go back and see that. Alright, so if you understand this, awesome. Let's move on. If not, call me over and I'll help you out. Alright, last but not least, we're going to do problem number 7, which has to do with kites. Alright, so we know that number 7 is a kite, and we are given that WX equals 14. Alright, let me rewrite that. 14. Oh my goodness. There we go. Alright, and we're given that WR is 8. We want to find RZ, so we're looking for this side right here. Alright, so first things first, we know that these diagonals are perpendiculars, so that's a right angle. We also know that if this side is 14, this side also has to be 14 because these sides are congruent if this is a kite. So this is a right angle as well, and if we're looking for RZ, let's call it X, we can use the Pythagorean theorem to find it. So we want to say 8 squared plus x squared equals 14 squared. And that's going to help us find RZ. So then we would say 64 plus x squared equals 196. Subtract 64 from both sides. X squared equals 132. Take the square root of both sides, plug the square root of 132 into your calculator, and you get x is approximately 11.5. So our final answer is that RZ equals 11.5. And we're done. So that Pythagorean theorem will come into play more than you know, and so don't forget how to use the Pythagorean theorem. All right, one more slide, so hang in there. So we're just going to quickly review quadrilateral properties. So these are all the quadrilaterals that we've learned so far in this chapter. All right, since this is the last new lesson of the chapter, let's quickly recap. Quadrilateral properties. So we started by learning about parallelograms, and the properties of parallelograms are that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary, and that the diagonals bisect each other. Then we went and learned about rectangles. So rectangles have all the properties of parallelograms, and we know that the four angles are right angles, and that the diagonals are congruent. Then we learned about rhombi and squares. So rhombi have four congruent sides, as well as all the properties of parallelograms. The diagonals are perpendicular, and diagonals bisect opposite angles. And we learned about squares, and we know that squares have all the properties of parallelograms, rhombi, and rectangles. So using this little diagram, you can see we start with parallelograms. Rhombi have all the properties of parallelograms. Rectangles have all the properties of parallelograms. Squares have all the properties of rhombi, of rectangles, and of parallelograms. Now kites are off over here all on their own, and we just learned about all the properties of kites. Trapezoids. Trapezoids are also over here all on their own. Trapezoids have only one pair of opposite sides or parallel called the bases. Consecutive angles are supplementary. Supplementary, 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 supplementary. The mid-segment of a trapezoid connects the midpoints of the legs, and it's equal to the average of the two bases. Isosceles trapezoids have all the properties of trapezoids, but they also have non-parallel sides or legs that are congruent. The diagonals are congruent, the base angles are congruent, and the opposite angles are supplementary. So, when you go on to do the next thing, remember to pick up this sheet, which I have printed out for you. So, it's a great tool to use to study. But also, don't forget about those properties of kites, because you need to know those as well. All right, I hope you learned a thing or two today about trapezoids and kites. And that concludes our chapter on quadrilaterals. So, look to your teacher or look to the board to see what to do next. And I hope that you have a great day.